Okay, so it is time as promised for us to make the transition now from polygons or straight-sided figures into circles. So first, I want to define some vocabulary of circles. Some features of a circle that we should already know. That, of course, is what part of the circle? The center of the circle. What's that feature of the circle?
Radius.
That is a radius.
Ray.
What's that called?
Ray.
What's that called? A chord. There we go, Mike.
Chord.
A chord. A chord is any segment that has both endpoints on the circle.
What am I thinking about? What's a ray?
A ray is just starts at a single point and goes on forever in one direction.
Okay.
A chord that happens to contain the center of the circle is called a diameter. Now there's a relationship there between the diameter and the radius. What is it?
Half.
The diameter is equal to 2 times the radius. So the radius is half the diameter. Yep, either way. What is the distance around the circle called? Circumference. There's a relationship between the circumference and the diameter, which is what? Well, for diameter, it'd just be pi times diameter.
Oh.
Or 2 times pi times the radius. Now, those are the standard features of a circle that we should already know. Of course, let's throw in there the area. What's the area equal? Pi times radius squared. Some features of a circle that we may not already know. Let's say we take that chord and we extend it on so that it cuts through the circle. Not only it doesn't end at the circle, it cuts through the circle. Can anybody tell me what that is called? Secant. A line that just touches the outside edge of the circle but does not penetrate it is called a tangent. Means to touch. And it actually touches the circle at exactly one single point. Now there's a special relationship between the radius of a circle and a tangent. Can anybody tell me what it is? A radius to that point of tangency always forms a right angle with the tangent. Now if I have a chord, that piece of the circle that is cut off on the between the chord and the edge of the circle is called that's called a segment. What if I have 2 radii of a circle? That area of the circle that is between the 2 radii, that looks like a pi wedge, is called a sector, yes. And a piece of the outer edge of the circle is called an arc. The angle between 2 radii, gentlemen, people can't hear. The angle between 2 radii is called a central angle. Now it's called that because, of course, its vertex is at the center of the circle. Often we will describe the arc, rather than describing it in terms of length, we'll describe it in terms of whatever its central angle is. So if this is a 32-degree central angle, we will often describe this as a 32-degree arc. So be careful. If I ask for the arc, usually it's asking for the degrees. If it asks for arc length, Then it wants it centimeters, inches, whatever units of length the radius is in. We're going to get to that. There's another type of an angle called an inscribed angle. An inscribed angle has its vertex on the circle itself, like that. The size of that inscribed angle is going to be half of the intercepted arc. So this is a 32-degree arc. This will be a 16-degree angle. Or the other way around. It's a 16-degree angle. It has to be a 32-degree arc. And we're going to look at those arc and angle relationships more coming up in the future. 15, 20 minutes from now. So I've got a circle, has a radius of 8 inches, a central angle of 40 degrees. I want you in your notes to find the circumference of the circle. Find the area of the circle. This is the whole circle, so we don't really need that central angle right now. Find the circumference and area for me quick. What'd you get for circumference? Equals pi times 16, right? So 50 point, if I use 3.14, I get 50.24 inches. If you use the pi key, you might get 50.26. For the area, pi times 8 squared, which is about 201 or 200.8, something like that. So we're going to call it 201. Times it 200.9 something if you use pi. So anyway, we found that. Does anybody recall how we would find the area of the sector? The area of that sector is a fraction of the area of the whole circle. That little symbol there, that's A. This would be A with a circle by it for the area of a circle. This looks like a little cone there. It's actually a pi wedge. It's the area of a sector. Is found by taking that area of the circle, 201, times what fraction of a circle is it? Well, there's 360 degrees in the full circle, and we have 40 of them. So that's 40 360ths. 22.3 square inches is the area of that sector. Does everybody follow that? Just take the whole circle times that fraction, the central angle times the over 360, sorry. How about the arc length? How do you think we're going to do that? Well, we have the 50.24 circumference. It is the same fraction of the whole circle. So that's going to be what? 5.56, something like that.
5.585.
5.59 or 5.56. $5.58. That's going to be just inches because that's the length. Does that all make sense? Okay. So I'm going to throw this one out there for you guys to try. That's 60 degrees. This is 10 feet. Find one. I'll put this in red here so you know which arc length I'm talking about. The arc length. 2, sector area. 3, this is where you really start to love me. The area of the segment. I'm going to pause.